Good morning, ICP students. Today, we are moving on to Chapter 15. You should have taken your Chapter 14 test from Friday. If you did not get to that because for whatever reason your power was out, please make sure to do that at some point sooner rather than later. Otherwise, it will be turning into a 0 on a test. So make sure that you guys are attempting it. If you have questions, just send me an email. Which a few of you have been doing, and I've been doing my best to answer those for you. All right, so today, chapter 15, we are looking a lot at energy. Okay, so what is energy? Well, the definition of energy that our book uses is the ability to do work. Now, if you guys want to look at work, work is the transferring of energy. So energy is the ability to transfer, to do work. Kind of repeats itself there. I'm just seeing that. But when we think about energy, you can think about like electricity. You can think about the sun's energy. You can think about wind. You can think about movement. You can think about potential energy. We're going to be diving all into that as we go through chapter 15. Now, the first thing we're going to look at is something called kinetic energy. Now, kinetic energy is basically the energy of something that is moving. So how much energy that thing is going to have. Now, kinetic energy and momentum are very closely related to each other. Momentum is based on your mass and your velocity, just like kinetic energy is. So as we look at kinetic energy, it's kind of the same idea of momentum, but this time it's referring to energy, so the energy of motion. Now, kinetic energy has this equation here. Kinetic energy equals 1/2 m times v squared. Now, if you want to write it out a different way, kinetic energy equals 0.5 times the mass of the object moving times its velocity squared. Now, when you do this equation, you want to square the velocity before you multiply anything. All right, so make sure you're squaring the velocity before you multiply the mass, before you multiply by 0.5. So let's look at a few examples here. So what is the kinetic energy of a 1,000 kilogram car at each of the following speeds? All right, so remember, kilograms is mass. So if we want to find the kinetic energy of the car in scenario A, so we have kinetic energy. So kinetic energy equals 0.5 times, so 1.5 times the mass. So our mass of our car is 1,000 times velocity squared. So our velocity or our speed is 20. So we want to take 20 and we want to square that before we multiply by 1,000, before we multiply by 5. Now if we take 20 squared, that gives us 400. So if we take 400 times 1,000 times 0.5, you end up with the kinetic energy of 200,000. All right, so we have our kinetic energy of our car moving at 20 meters per second is 200,000 joules. So that is our kinetic energy of our car. Now, if we were to do it at B, so 40 meters per second, we would still follow the same process. The only difference is 40 would be squared this time. So when you take 40 squared, you get 1,600, which you then times by 1,000, which you then times by 0.5, and that gives us 800,000. So at 40 meters per second, a car has 800,000 joules of kinetic energy. Now, if we were to do the same thing at a speed of 60 miles or meters per second, we start by squaring 60. So we take 60 times 60, which gives us 3,600 times 1,000 times 0.5. That would give us 1,800,000 joules for our kinetic energy. Now, that brings us to these two questions down here, D and E. Now, in order for that car to get to that kinetic energy that you see, it has to burn the gas in order to get to that speed, to have that much kinetic energy. Now, what this tells us about the amount of gas used is that when you are traveling at higher speeds, you are using a lot more gas to get to that kinetic energy. So traveling at higher speeds starts to become less efficient because you have to use so much more gas in order to get to that kinetic energy. What this also means that if you are in an accident or in a crash, the faster you are moving, the amount of kinetic energy that will be involved in that crash increases very, very rapidly. So it's almost increasing exponentially. So at 20 meters per second, you have this much kinetic energy. At 40, you have this much. And at 60, you have this much kinetic energy. So what this is telling us is the amount of kinetic energy involved in a crash increases exponentially the faster a vehicle is moving. So that's just a couple of things to throw out there. So remember, kinetic energy is the energy of movement. Okay, it's based on mass and your speed. Now, potential energy is going to be the stored energy due to position or shape of an object. So when we look at potential energy, the object itself is not necessarily moving. It could be, but it could not be. It's basically the stored up energy. Now, there's a couple examples here, a wrecking ball, a bow. With that wrecking ball, when you have that wrecking ball and you're swinging it, if it was straight up and down, it would be right here. But when it's out here, it's almost like it's on a pendulum. It's swinging. And because of its position compared to where it wants to be, so the wrecking ball wants to be right here, but it's over here. That means it has potential energy, and that potential energy causes it to pick up speed as it moves until it crashes into an old brick building. Now, a bow is another example of something with potential energy. And this one is due to its shapes and its position. All right, so when you draw back a bow, you are bending the arms of the bow. Now, this is storing up energy in the limbs of this bow as it's bent back because the limbs want to return to where they normally are. So as you let go, all of a sudden there's nothing holding the limbs of the bow back anymore, and so they go back to where they want to be, which pulls the string, pushes the arrow out, giving it a lot of kinetic energy. So potential energy is based on storing energy somehow. Now, the most common type of potential energy is gravitational potential energy. And basically, all that is based on is how high an object is off the ground and its mass. All right, now we do have an equation for that. Gravitational potential energy equals mass times gravity times your height, the height of the object above the ground. So mass times gravity times height. Now, if you recall, on Earth, gravity is going to be 9.8. And then the mass will be the mass of the object, and the height will be however high it is off the ground. So the higher you lift an object, the more potential energy it's going to have. So think about your cell phone. When you have your cell phone and you drop it from a couple feet off the ground, it hits the ground, it doesn't really crack. The reason for that is when you only had it a couple feet high, it had a very low potential energy. It wasn't very high. Now, if you take that phone and you are standing on the roof of your building and holding it off the edge, all of a sudden it has a very high potential energy because it's very high off the ground. So if you dropped it from the roof of your house or roof of a building, when it falls and hits the ground, because of all the potential energy that was stored, it's with turning into kinetic energy. Typically, your phone is going to crack or break in that situation. Another type of potential energy is elastic potential energy. This is the energy stored due to stretching or compressing. If we go back to the bow situation, the compound bow or recurve bow, those are dealing along the lines of elastic potential energy. Another example is a rubber band. So when you stretch that rubber band and you hold it, you've provided potential energy through the rubber band. And so as soon as you let go of that rubber band, all that potential energy turns it into kinetic energy, causing it to fly. Springs are another great example of elastic potential energy because when you have a spring, you start to pull it apart, you're stretching it, putting potential energy into the spring itself. All right, so we're going to go ahead and we're going to stop there. A few key things from today. We have kinetic energy, which is the energy of motion. We have potential energy, which is based on the shape or the position of an object. Those are our two main types of energy. We had an equation for kinetic energy, and then we had our equation for gravitational potential energy. So anyways, folks, that is all we have for today. Go ahead and attempt your assignment. If you have questions, send me an email.